Testing, testing. 1, 2, 1, 2. Boats, let's go. Boats, let's go. The PG version. All right, so we still have like about a minute and a half remaining before we get the party started. I guess we can do some announcements. Uno minutos más. Boats, let's go. Boats, let's go. 30 seconds. Fifteen seconds. T minus 10 and counting. 9, 8, 7, 6, 5, 4, 3. All right, gentlemen and gentlemen. All right. Okay, so welcome. This is it. This is the culmination, right? This is the last of the new material. So pat yourself on the back, pause for applause. All right, this is the last of the material. You've essentially done it. The remainder is pretty much formalities, right? So after we finish today's lecture, then it's just review and just submitting our final documents. There is an extra credit opportunity in the form, but it's going to be automatic if I can do it. What I like to do is I'm just making you aware so that you can try to maximize your score. But what I like to do whenever possible, I'll take your overall MyMathLab score and scale it and so that it counts as 10% of your overall grade. So if I can do that and it doesn't skew the grades too much, I'm open to that. It'll be automatic. So on your end, if you want to maximize it, then what you would do is maximize your MyMathLab score. All right. So if you look at it, just try to, boost your older assignments. If you are going back and submitting assignments to boost your overall score, I would encourage you to prioritize your exams first because that's where you're going to get the most bang for your bucks. And then you want to prioritize the homework class because that's going to be a lot of work for minimal points. Give me just a moment. Right there. Check. Let me check. That's look good. Okay. Yeah. So again, just to reiterate, if you are going back to do your older assignments, I would encourage you to prioritize exams. That's where you get the most bang for your bucks. That's where you're going to see the heaviest impact as far as grade moving. Homework is really there to just get you ready for the exams, and we try to give you some type of compensation for it. So it's a lower weight. It's a lot of work, but it's a lower weight. But it's that's how you prepare for the exams. Let's see our tentative schedule. So today we'll work on the final section, which should be section 6.4, system of equations in two variables. And then next week on Monday, we'll meet on Monday, the 25th. That'll be our first day of review. So we have 3 days of review. Monday, we're going to review, focus on exam 1, so all sections pertaining to exam 1. The remainder of next week, we're going to be off for the holiday. So I think that Wednesday the school closes at noon. Don't worry about it. I'm not going to be here that day. All right. So you're the only class that I would meet before noon. So I'm just going to let you guys go. So we'll have after Monday, we'll have the remainder of that week off. Be sure to enjoy your holidays. I don't know. I kind of want to dive into it, but just long story short, I just try to maximize or enjoy your holidays. Like do whatever work you need to do, but try to, enjoy the time with your friends and family because no day is promised. As I kind of go through these decades, every time I turn around, people are dropping like flies. I've lost like cousins that are younger than me. I've known them my entire life, their entire life, and just people are dropping. You're like, geez, so like flies. So whenever possible, just try to maximize those times with your loved ones whenever possible. So that'll be next week after Monday, and then after the holidays and festivities, we come back on December 2nd and December 4th. So Monday, December 2nd, we'll focus on exam 2. So all sections pertaining to exam 2. And then Wednesday, December 4th is going to be our last day in class. That'll be our last live session. And then we'll focus on exam 3 along with these 2 additional sections after exam 3 as far as review. So then that Thursday, December 5th and the 6th are a reading period. Also, I think there is a course evaluation. So check your email. Be sure to fill that out. So yeah, that's in your Morehouse email. So check that out. And it's a good idea to go ahead and submit those items. Again, the reading period is that Thursday and Friday, December 5th and the 6th. And then final exam week is that second full week of December, which is essentially the 9th through the 13th. Right now, I'm still under the impression that I will be hosting your finals, so you can anticipate it to become available that Sunday, December 8th at 11 a.m. And you can access it for full credit up until Friday, December 13th. Friday, December 13th is a hard deadline, not only for the final, but for all of our assignments. So you can access the final for about 5 days. Again, after that Friday, December 13th, then everything's going to lock out. Idealistically, you want to get everything in order leading up to the exam. So that way, when you submit your final exam should be the last thing that you submit. You don't really want to be in a boat where you submit your final, then you have other things that you got to do, right? So this is a great time to go ahead and get caught up on any missing assignments, any missing exams. If you have questions from exams, you can actually ask questions. You can get help. You don't have to, be alone. You can ask me. You can collaborate with the tutor. I just need each of you to submit your assignments to the best of your ability, right? You can work together like it's going to be okay. Okay, and as usual, if you have questions, feel free to keep them to yourself. I'm kidding. Feel free to unmute yourself to get my attention or put it in the chat or the Q&A. You know how to reach me. You have my office cell phone. You have my email, text, call, Telegram, whatever. So you know how to reach me. Okay. So that concludes our morning announcement. So let's go ahead and focus and let's get the party started and finish out this last one strong. And hopefully we can position as many people as possible for success. Okay. And again, if you need help or if you have any concerns, you have to speak up because a closed mouth doesn't get fed. That's part of the challenge of growing up and being an adult is learning how to speak up for yourself. We do the best that we can on our end, but a closed mouth don't get fed, basically. Okay. And then also another thing I learned from one of my former students, she was like, if you're talking to somebody and they're not saying what you want to hear, you're just talking to the wrong person. So you gotta find someone else to talk to. So and that permeates to any and everything, even me. Like if I'm not saying what you want to hear, you just got to find somebody else to talk to. But I try to be reasonable. Okay, anyway, I try to make an effort. Okay, that's a little bit distracting. Let's do this real quick. Okay, I think we're good. All right, so we're here. All right, let's see. All right, so our final section comes from chapter 6, is further topics in algebra, and it's section 6.4, systems of equations in 2 variables. A few objectives: 1, verify solution to a system of equations. 2, solve a system of equations by the graphical method. 3, solve a system of equations by the substitution method. 4, solve a system of equations by the elimination method. And 5, solve applied problems by solving system of equations. Okay. So a few definitions. A set of equations with common variables is called a system of equations. If each equation is linear, then it's a system of linear equations or a linear system of equations. If at least one equation is nonlinear, then it's called a nonlinear system of equations. Here's a system of 2 linear equations and 2 variables, right? So with this system of equations, notice that like the highest power on any variable is a 1. So these are 2 linear equations. We could solve each equation for y. Like we'll explore some techniques. We have at least 3 different techniques that we can use to solve this system of equations, right? Okay, so let's keep going. A system of equations is sometimes referred to as a system of simultaneous equations. A solution of a system of equations in 2 variables, x and y, It's an ordered pair of numbers A and B, such that when X is replaced by A and Y is replaced by B, all resulting equations in the system are true. The solution set of a system of equations is the set of all solutions of the system, right? So as we start to explore solutions to the system, these are going to be all ordered pairs that make all equations true in the system, right? If it makes one equation true and the other not true, then it's not a solution of the system. Okay, let's keep going. Okay, so I think I more than likely I left the notes on this one because it might be fairly straightforward. Verify that the ordered pair 3, 1 is the solution of the system. So in order to verify that 3, 1 is a solution, basically plug it in, right? If it's an ordered pair, that means the first component is our X, the second component is our Y. So we just let X be 3. Okay, there's the person. So somebody just joined and it says Zoom user. Let me kind of pause just to make sure the audio is there. Make sure that you're showing your student name. I know at least one other day I know that that person didn't get credit, so make sure that your student name is showing, so you're not accumulating unintentional, unexcused absences. So just make sure that your student name, your first name and last name is showing. If it says Zoom user, I don't know who you are. I'm going to mark you as absent. So just hopefully you're hearing that. So make sure your student name is showing. Okay. So to verify. Yeah, again, so we let X be 3, let Y be 1, and we basically substitute the corresponding components, right? So I feel like this one is straightforward. I'm okay with us not exclusively writing this one out. I think you guys know how to plug in at this point and then, simplify, all right? So again, if we plug in X is 3 and Y is 1, we see that, okay, cool. I don't know what day that was. I'll check like the past few sessions. If you have trouble with attendance, you shouldn't. I don't think you will, but if you have trouble with attendance, I'll just try to make a mental note and because I know there was at least one day. So I'll just go back and give you credit for at least one day. Because I didn't say nothing to nobody because I didn't want nobody to be like, oh, yeah, that was me. I didn't want nobody to try to claim it. So I was like, okay, I'll just wait until I see a person again. So I'll just try to make a mental note and I'll try to do something in the class to kind of go back because I know there was at least one day. Okay, anywho. Okay, so I feel like that one was straightforward. Now, so in the previous one, we were given the solution, right? And we just wanted to verify that it was a solution. We saw that when we plugged that order pair into each equation, it made both equations true. So that one was straightforward. So now we want to see, okay, well, how do we find that solution to a system of equations? So again, here they ask us to use a graphical method to solve the system of equations. Okay, so I'm curious. I want to try something. So I think what I want to try, first I want to try Desmos. All right, I want to try Desmos. Desmos. I want to see the capabilities, the power of Desmos. Obviously, I wanted to say the power of the dark side. Open the graphing calculator, please. Thank you. Okay. So what I'm gonna do, I'm gonna type this as I see it, and just to see what happens, right? So if we're graphing, right? So again, notice that the highest power on any variable is 1, so these should be both linear equations. And let's just graph it and see what happens. So we have 2x minus y equals 4. I'm just going to hit enter. I'm going to assume that that's correct. Then I'm going to put 2x plus 3y equals 12. Notice something that happens, right? So notice we do get 2 lines like we anticipated. We can verify some points like the intercepts, right? Like for the second equation, it looks like our y-intercept is what? What is that, a 4? So when x is 0, we do indeed get 4. So yada, yada, yada. You can verify all those other points. Now we have this point of intersection, right? And all I did was type in the 2 equations, just like you see them in Desmos.com, a free virtual graphing utility. I already knew there were going to be lines. We see where they cross, and I just clicked on the point. All I did was type it in, and that's just awareness, right? That's just because I knew of this site. I just typed it in. I didn't even think about it or anything. I just used my resources, right? So 3, 2, pretty straightforward, right? So what we're saying is that these 2 lines cross at the point 3, 2. So we're saying that when x is 3 and y is 2, that should make both equations true. Let's just do a quick check. 3 times 2 is 6. Minus 2 is indeed 4, so the first equation checks out. 3 times 2 is 6, plus 3 times 2 is another 6. 6 plus 6 is indeed 12. So this order pair does make, that would be the solution to the system. It's not always that straightforward and easy, but it doesn't hurt to just check and look and be aware of that capability. So we already have the solution. We got 3, 2. So now, yeah, graphing. So if we were doing this manually, then we would graph both equations. These are linear. We could solve for y. Like the first one would be y equals 2x minus 4. Or they're graphing the intercepts, right? They're using the intercepts. So if we're going to find the y-intercept, set x to 0, yada, yada, yada. So they're plotting each line by using the intercepts and then seeing where once you draw the lines based on the intercepts, again, you'll see where they cross at the order pair 3, 2. Again, we used a graphing utility. The solution to the system was the point of intersection. The text used the intercepts of each equation to graph the lines and then just visually looked at where the lines crossed. All right, not bad. So we saw at least 2 different ways to find this result, this solution. Okay, that was fun. And we checked it already. We checked that our solution made both equations true. Okay, so we've seen one way that solutions appear with systems of equations, right? We might have one solution, but are there other ways that these things can unfold, right? So here we have solutions of systems of equations. The solution set of a system of 2 linear equations and 2 variables can be classified in one of the following ways. One solution, which is like what we just saw in the previous example, the system is consistent. We say that the system is consistent and the equations are said to be independent, okay? So when we have one solution, we say the system is consistent and the equations are said to be independent. Another case that happens is when we have no solution, right? In other words, the lines don't ever cross. They never touch each other. This occurs when we have 2 lines that are parallel. We said that the system is inconsistent, right? So consistent, we had a solution, and they're independent, we had one solution, right? If they don't cross, then we say the system is inconsistent, right? So no solution. And then the third scenario that tends to happen, we have infinitely many solutions. In other words, one equation is a multiple of the other. Or in other words, one line is on top of the other line, right? So the lines coincide. We said that the system is consistent, meaning we have a solution, at least one solution, and the equations are said to be dependent. In other words, like dependent is like, one equation depends on the other, or one equation is a multiple of the other, right? So we'll have infinitely many solutions, all right? Okay. So again, consistent means we have a solution, and then independent means we have like one solution or a finite number of solutions. Inconsistent means there's no solution, the lines are parallel. And then consistent and dependent means we have infinitely many solutions and one equation is a multiple of the other. Okay. Okay, so there's still a little bit more to explore here, but that's the meat and potatoes. So here we're asked to solve the system by substitution method. Let me give myself some space. Yeah, let me just give myself some space. So we needed to be, this is slide, you're jumping around. This is slide 15. Okay, I just need, let me see, can I copy? So we'll go back to 15. Right there, can I paste? Nice, okay. All right, let me get a copy of this guy. So again, they want us to use the substitution method. Let me take it to about here. It's irking me a little bit, but I'll work around it. I want to duplicate this one. I just want it to like, there is fine. Go down just a little bit. That's decent. Come on. And then this one right here. I just want it to like there. Then let me see if it's cut off. Crap. Oh, well, that's fine. Don't worry about that. Where's my key? This is good. I'm going to put you about like right there is fine, and expand. That is good. So we have a copy of the question. And we're asked to solve the system by the substitution method. So with substitution, the key word is what? Substitute. So we're gonna the way we do the substitution method, basically we solve one equation for one variable, so we get like y equals something. Then we take that and plug it into the other equation. When it comes to the system of equations, every time you have an unknown, you need an equation. Notice here in each equation we have two unknowns. That's why we're given two equations, right? So every time we have an unknown, we need a piece of information specifically for that unknown. Right? Or every time we have an unknown, we need an equation for each unknown. So we have two unknowns. That's why we have two equations. It looks like it'll be easier to isolate one of the variables in equation 2. So I'm going to isolate y in equation 2. So let's start with equation 2. We got this 2x equals 9. Okay. So I'm going to add 2x to both sides. We get y equals 2x plus 9. Okay. So we solve for y from equation 2. Then we're going to take this and plug it into equation 1. So we're going to replace the y with this isolation from equation 1. So we got this 2x minus 5 times y equals 3. Let me do y in blue. Let's do orange, just because I would do yellow, but I don't like the way the yellow looks on the screen. I feel like it's harder to see. So, okay, so we're replacing y with the 2x plus 9. Okay. So then here, let's distribute that negative 5. So we'll have 2x minus, what is that, 10x minus 45 equals 3. Notice at this point we have one equation, one unknown, so we can solve. Okay. What is that, a negative 8? And if I add the 45 to both sides, that becomes what, 48? So then, so x equals what, is that, a negative 6? All right, 6 times 8 is 48. Okay, so we solve for x. So now let's go back and solve for our y. Again, we said that y equals 2 times x plus 9, but our x is negative 6. I'll just do the rest in black. That's a negative 12 plus 9, which is what, 3? No, plus 9, which is negative 3. Okay, so we got y equals negative 3 and x equals negative 6. So our claim is that the solution to the system looks like it's negative 6 comma negative 3. Okay, so let's do a quick check to make sure that this works. Okay, so then 2 times negative 6 is negative 12, plus 15 is indeed a positive 3. Negative 3 plus 12 is indeed 9. All right, so this order pair makes both equations true. So this would be the solution to our system. Okay. Negative 6, negative 3. And again, we could have done the same technique as we did in Desmos, but I just wanted to showcase the substitution method. Okay. Again, the idea behind the substitution method, you solve one equation for one variable. Where'd it go? Here it is. So negative 6, negative 3. You solve one equation for one variable, and then you substitute that into the other equation. Then once you solve for one variable, you go back and solve for the other variable, and then test to make sure that it works. That order pair works in both equations, okay? All right, so hopefully we're all aboard, and we're not all bored. I know how this stuff can be drawn. It can drone. Okay. Okay. So, okay, let's give this one a go. We'll go ahead and do the substitution method again, and let's just see what happens, right? So it looks like in equation 1, fairly simple to solve for y. So from the first equation, we'll get that y equals 3 minus x. Okay. So then if I take this and plug it into the second equation, let's see what happens. So then 2x plus 2 times y equals 9. Yeah, our y is 3 minus x. Okay. So then we can distribute. Okay. So then we'll get 2x plus 6 minus 2x equals 9. A number plus its opposite, they add to 0. If we subtract 6 from both sides, we'll get 0 equals 3. This is false, right? So when something like that happens, that means that there's no solution. Right? And the hint was, the title said, attempting to solve an inconsistent system of equations, right? I started to say it, I was like, let me not say anything. And I just want you to see, sometimes it will appear like this, right? You'll be going through, your variables will cancel, and you'll finish with a false statement. So if your variables cancel out like that and you finish with a false statement, then there is no solution. Let's go. Man, that never appeared. Is it frozen? No. Okay, I'm just gonna keep moving. Anywho, let's keep going. Okay, so that one was no solution. Solve the equation for y in terms of x. I think they did the same thing we did. And then if we were to graph these two lines, we'd notice that they would be parallel. Right? They have the same slope with different y-intercepts. Okay. Solve the system. So far, again, we've only done the substitution method and graphing. I think I can resonate with the substitution method, because in equation 2, it looks like it's fairly easy to solve for y. If we solve for y from equation 2, add, we'll get y equals 6 minus 2x. And then if we take this and plug it into the first equation, 2 times y equals 12, okay? And again, our y is this 6 minus 2x, and then we distribute. So notice with the past 3 examples, we've done the same thing, and we just had to interpret the results, right? They all kind of behaved a little differently. They took on a life on their own. Each one took on a unique experience. So we started the same way, but then we had to interpret, okay, when this happens, what does that mean, right? That's what a lot of mathematics is. Okay, anyway. Okay, so we get this 4x, 6 times 2 is 12, minus 4x equals 12, okay? A number plus its opposite, these cancels. If we subtract 12 on both sides, we'll finish with 0 equals 0. Notice that this is a true statement. So this is similar to the previous, but in the previous, we finished with the false statement. In this instance, we finished with the true statement. So then this means that we have infinitely many solutions, and that one equation is a multiple of the other. If we take equation 2 and we multiply it by -2, we'll get the first equation. So that means we have infinitely many solutions. In other words, one equation is a multiple of the other. So then the way we capture the solution, we're going to do it like this. So no matter what x we choose, y is going to take on the form 6 minus 2x. So then the solution to the system looks like this. Okay. So again, let me just do that one more time, just to reiterate it, because it's a little bit foreign. Come on, delete. This thing is like struggling. All right, okay. So again, when we have infinitely many solutions, no matter what x value we choose, y is going to take on the form from the left of that 6 minus 2x. So this is how we capture infinitely many solutions. Okay, and then you can test a few points. Like for instance, if x was 0, that means the corresponding y would be 6. So then the order pair 0, 6 is one possible solution to the system. Notice that 6 times 2 is 12, and -6 is equal to -6. You can choose your favorite value of x. Let x be, I don't know, 3. So then the y happens to be 0. Okay, so 4 times 3 is 12, -2 times 3 is -6, right? Again, you can choose your favorite value of x to test. You can find infinitely many values of x are going to work here. All right, you just need the proper corresponding y. Okay, but this is how we capture all of the solutions of a dependent system. Okay. Oh man, we only got like a little over 10 minutes left. Party's almost over. What a bummer. All right. Okay, anywho. Okay, so I think they did something similar. They solved for y, and then they finished with the true statement. All right. So the solutions are of the form x comma 6 minus 2x, and the solution set is that guy there. The solution set consists of all order pairs x and y lying on the line with this equation. The system has infinitely many solutions. Okay. Again, one equation is a multiple of the other. All right. I think the chat looks good. Oh, let me check the chat. I think we kind of addressed that. December 13th. So the hard deadline for all assignments is December 13th. There's a question that said they just were trying to clarify the hard deadline. And yeah, cool. We'll again, I'll check that a little bit later. Okay. Let me see. Okay, the elimination method. Let me give myself some space. Can I just paste? That would be nice. I probably can't. Paste. Oh, look at that. Okay, cool. Still saved. All right. Let's see if I can like this. Maybe that'll behave a little bit better. Copy. There. So like that. Like that. That looks good. Come on. Let's duplicate. Trippy. How's it behaving like this? Let me just back out. This one. There we go. All right. So for this one, I'll cut about there. And this one, crop. All right, that is decent. Okay, so the elimination method. So far, we've explored two techniques for solving a system of linear equations in two variables. The first was looking at the graph, and the solution would be where the lines cross. The second we explored was the substitution method, where we solve one equation for one variable and then take that and substitute it into the other equation. So then with the elimination method, we're essentially doing a series of row operations where we're going to eliminate one of the variables and then solve and then kind of reverse substitute. Let me start by getting another copy of this guy. So we got this 2x plus 3y equals 21. Then we have 3x minus 4y equals 23, okay? So the first goal, when we're doing the elimination method, we're going to pick a variable, and we're going to multiply a row by any non-zero number such that that variable has the same coefficient with opposite signs. So let's eliminate the x, right? I just chose one at random between x and y, right? So the least common multiple between 2 and 3, we're going to get the coefficient to be 6 in both cases. We're just going to have one of them to be positive 6, the other to be negative 6, okay? So let's multiply this first equation by what, 3? So we're going to say like times 3 here, here, and here. We have to do it across the whole row. And then we're going to multiply the second equation by what? Negative 2. So we're going to say times negative 2 here, here, and here. Okay. So what this does is manipulate each equation, but it doesn't change our final answer. It manipulates them into a form that we can use. So if we distribute a 3 across that top row, 3 times 2 is what? 6. 6x plus 9y equals, what is that? 63. Okay. And then the second row by negative 2, we'll get negative 6x plus 8y equals a negative 46. So now we combine like terms, right? If we add the two equations together, this guy cancels this guy. This is 17y equals, what is that? 13 plus 4, is that 17? So then y equals 1. Divide both sides by 17, y equals 1. Okay. So we solve for y. Now we want to take this and plug it into either equation. I'm going to plug it into the second equation just because. 3x minus 4 times y equals 23, but our y is 1. Okay. So then it's going to be what? 3x minus 4 equals 23. Add 4 to both sides. 3x equals 27. Divide both sides by 3 is at 9. Okay. So we have our x, we have our y. So our claim is that the solution to the system is going to be the ordered pair 9, 1. Okay. We should check. I could resize it so I can show the check. But it's not necessary. I think I'm gonna just do it audibly. So 9 times 2 is 18 plus 3 is indeed 21. 9 times 3 is 27 minus 4 is indeed 23. So this order pair makes both equations true. So this will be the solution to our system. Now let's see what they do. Okay. So they chose to eliminate y. We chose to eliminate x. It's like potato, potato. Choosing two different, like we started at Morehouse and we chose different routes to get to Stone Mountain. At the end result, we still made it to Stone Mountain. So, it's just two different ways to do the same thing. So they eliminated the y. So they multiplied the first equation by what? 4. And the second equation by 3. Okay. And then so they got something like this. They still got x was 9, just like how we got, and they got y equals 1. They got the same solution. And then they checked. Still says Zoom user. So let me see. Can I see it here? Yeah, no audio is there. Okay, that's one of this. Okay. All right, let's keep going. Solving a nonlinear system by linearizing substitution. Okay. So we're going to use a technique here called the substitution method. So in this form, it might be challenging to solve it. So we're gonna rewrite it. We're gonna do a substitution to put it in a form that's more manageable, right? So if we try to solve this directly, we may or may not be able to do it, but we can change the form into something that's more amicable, right? So the trick here is, let me see. So we're gonna let u equal 1 over x, and we're gonna let v equal 1 over y. Okay, so we're going to replace 1 over x with u. We're going to replace 1 over y with v, and then proceed in that fashion. So then if we do these substitutions, the system becomes 2u plus 5v equals -5, and then 3u minus 2v equals a -17. So again, you can call this U substitution. It's just a technique that we have for instances like this, okay? Okay. So then now we can use our favorite method. I'm going to eliminate u. I'm going to do the elimination method. So I'm going to say this row times 3, and this row times a -2. Okay. So then the first row becomes what? 6u plus 15v equals -15. The second row becomes negative 6u plus 4v. Is this the same? I don't know. Let's keep going. What is that? 34? Positive 34? Okay. So then now we add the two equations together. A number plus its opposite adds to 0. 15 and 4, that's going to be a 19v. Let's see. 14 plus 5 is 19. So divide both sides by 19. V equals 1. Okay, so if V is 1, I'll plug it into the first equation. Let me highlight it. So then 2u plus 5v equals negative 5, but v is 1. So then 2u, if we subtract 5 on both sides, we get a negative 10. So then u equals negative 5. Okay. Okay. So now what we want to do is reverse substitute, right? So like if u equals negative 5, that means that 1 over x equals negative 5. And the other one is what? 1 over y equals 1. Okay. So then we can cross multiply. Did we get this right? I feel like something's off. We'll check. We'll figure out if it's correct or not. So then we can basically flip both sides. We get x equals a negative 1 over 5 and y equals 1. So our claim right now is that the solution to the system is going to be a negative 1 over 5, comma 1. So we need to check and make sure that this works. Okay. So if x is a negative 1 over 5, that first equation is going to become what? Negative 10 plus 5 is indeed negative 5. That checks out. That second equation is going to become negative 15 minus 2 is negative 17. So this checks out. So this worked, right? So this ordered pair makes both equations true. So it is indeed the solution to the system. I feel like there should be questions, but it's okay. If you need time to like mull over it and process it, and I get it. It's okay. Okay, but this worked. All right. Okay, let me see. Replace 1 over x by u and 1 over y by v. I think we got the same thing. They eliminated the u. V was 1. I think they did everything the same as what we did. Okay, we did that. Okay. We got like about 5 minutes left. Find the equilibrium point if the supply and demand functions for a new brand of DVR are given by this system, where P is the price in dollars and X is the number of units. Okay, find the equilibrium point. So basically the solution to the system. Let's see. Okay, so notice that both equation is already equal to P. So we can do the substitution method. At first I was about to do the elimination method, but then the numbers were getting massive. Then I was like, well, elimination doesn't seem like the best route. So then I was like, okay, well, let's try the substitution, right? Again, the first equation is already equal to P. The second equation is already equal to P. So we can set those two equal to each other, right? So then if we do this, we'll have something like the following. We'll have this 80, 80 minus 0.0008x equals 60 plus 0012x. Okay. If we add the tenths, hundred thousandths, 8/10,000ths of x, add that to both sides and subtract 60. On the left, we're going to have 20. Let me see. 4, 4, 8, and 12 is 20. So 002. No. Yeah, adding, right? So like this, x. So then ultimately, x is going to be 20 divided by that. That's 2 over, let me see, 10, 100,000. So flip and multiply 1,000, right? Because that's 2 over 1,000. So we're going to say 20 divided by 2 over 1,000. 10, 100,000. Yeah. So when we flip and multiply, that's going to be what? 20,000 divided by 2. I think it's like 10,000. 10,000 units. rearrange stuff just a bit. Oh my God. That's decent. All right. So our claim is that the equilibrium point occurs when we produce and sell 10,000 units at the given price. Now we should check it by plugging in. I think I'm just going to go with it though. Just the time, and that pretty much just brings us to time. 20 divided by 0.002, 10,000. So supply function versus demand function. As the supply increases, the demand increases. If you have a low supply, then the demand is high. So then the sweet spot is the equilibrium point where supply meets demand. And it occurs in this instance when we produce and sell 10,000 units at, I think, $72 per unit. Okay. All right. Are there any burning questions before we go our separate ways? All right, gentlemen. So that brings us to the end of the new material. There's no more new material for this course at this moment. So yay, right? Okay, so have a great weekend. It's a good opportunity to go ahead and get caught up on like maximizing your exam scores to boost your overall grade, and then things of that nature. If there aren't any other burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, have a great weekend, gentlemen, and we'll meet back on Monday for to review exam 1 in preparation for the final. Happy holidays, and we'll meet back again for the holidays. Take care, gentlemen. Peace. Let me check the chat again real quick. You as well. Okay. Let me go ahead and do this. One more time.